Hi guys, and welcome back to week 2. Let's get started. This week we're going to be talking about epistasis. Epistasis is when the expression of alleles at one locus masks or modifies the expression of the other alleles at another locus. This means that different genotypes can lead to the same phenotype. In a non-epistasis situation, we'll have a 9:3 to 3:1 genotypic and phenotypic ratio with 4 phenotypes present that we can observe. If either of these ratios or the number of phenotypes that we can observe is different, we know that some kind of epistasis is occurring because one of our alleles is masking the others. Today we're going to talk about single recessive epistasis, specifically in the coat colors of unicorns. In this situation, if we have a homozygous recessive individual with 2 little a's, this will mask or modify the expression of the alleles at the B locus and will always result in a white unicorn. However, if there is a dominant A present, we'll then look at the B locus. If there's a big B present, this will result in a galaxy unicorn, and 2 little b's will result in a pink unicorn. So let's look at our pathway real quick. If we have 2 little a's, we lack our enzyme A and cannot move forward in our pathway. Therefore, we'll be stuck at our precursor with a white unicorn. However, if we do have a big A, we can continue on and look at our enzyme B. If we have 2 little b's, we'll be stuck at our intermediate and not move forward because we lack our enzyme big B, and we'll have our pink unicorn. However, if we have a big B, we'll have our end product with a galaxy unicorn. So here we're going to look at a dihybrid cross between 2 galaxy unicorns. Right here we have our chart displaying all the genomes, and up here we have our 9:3 to 3:1 genotypic ratio. However, if we look right here and here, we can see that this is single recessive epistasis because when we have 2 little a's, we are stuck at our white unicorn. We cannot move forward. So these will be grouped together and we will have a 9:3 to 4 phenotypic ratio. In this example, we're going to cross our galaxy with a white unicorn. Here's our genomes, and we'll have an 8:8 genotype ratio here. This is because we'll have 8 big A, big B galaxy unicorns and 8 little a, big B white unicorns. In this situation, we lose our pink intermediate phenotype and have a simplified 1:1 phenotypic ratio. These are my references, and thank you for listening.